eta VBB. RB1 plus RB2 we call as base to base resistance, RBB. Plus RB2. These are some of the points I have highlighted for you to start answering the questions if somebody is asking. So your PNPN, RB1, RB2, this bifurcation is not given there. You may question why that is there, but anyway, that is not given normally. That comes from the S curve characteristic directly. So I have revised the device. Now I'm going to see the questions. What kind of questions are asked? Device will be mentioned, characteristic will be mentioned, then questions will be framed. Question like that. This is the NR device. And its characteristic you have drawn like that. Complicated questions will not be asked. Questions will be slope of this one will be given, slope of this one will be given, slope of this one will be given. Okay. Here we call there is one voltage here, there is one current here. Okay. So this voltage we can call it as peak voltage, or we can say Wiley voltage. You can say is it coming at this point, so call it as a. Okay, I think I call it as peak voltage. Okay, peak voltage coming like this. This is your, we call VV is better, but anyway, tunnel diode is reverse. I'm calling this as my VP. I'm calling this as my IP, and this point will become my IV and VB. Okay, if I'm considering this point is there, but in some cases it is something like this, and your biasing is somewhere here. So your maximum voltage comes over here, this voltage comes here, this is here. So here you can say V maximum. This will be your V smaller, value of the voltage, sorry, IV, here IV and VV are just synonymous with each other. This is my VV, value of the voltage. This I can say as my VP. This one will be your IP. Okay. If something comes here, this is the voltage at which something will be asked. Suppose this voltage goes up to this point, analysis will be asked. Okay. There, slope of this line, slope of this line, and slope of this line will be, available in the form of these coordinates of these points. Coordinates of these points, here is the 0, 0 coordinate. The coordinates of these 3 points and this origin will give me slope of this thing. Normally we take as a slope. Otherwise, that equation of these lines will be given to you. Characteristic curves equation will be given to you in the question. Normally, for your this kind of short exams, you will be considering that straight line kind of thing will be given. So NR device characteristic will be given. Same thing is done with the diode. Normally, in the diode, we tunnel diode, we get the question like that. From here, it goes like this. It becomes your N curve actually. This is my V, this is my I. It is not S curve, it is N curve. Here it falls up to this point, and then it goes up to this point. So most of the time you consider the question here. In tunnel diode case, most of the time you get the question, this becomes my VV, this point, this becomes my IV, both become the value now. In the N curve, both become the value V and I. This becomes my IP, and this becomes my VP. VP and IP, this peak and this are taken as parallel, and at this point, if you are asked to do some kind of calculation, you will be finding it easy for you to compute. That's why the tunnel diode is N curve, that is voltage control. If it is S curve, that is your current control. Coming to the question, numerical questions now. Here, let me take fresh page, otherwise I have to drop in between. Is it okay now? I have revised the things?
Yes, sir.
Okay, it's fine. So now I'm coming here. If there is any question, you can raise it, okay? Even in the main exam also, this question will be converted to your subjective question that you will be writing the answer. Here you're putting a tick mark, you'll be writing answer there. Now, a device will be given, NR device, and its characteristic is given. I'm taking this. You can do it for the tunnel diode also. I'm taking this now. Your this point, your this point coordinate V and I, and another point here may be given if it is not this one like that. So like this, there will be current here, there is a voltage here. So this kind of three coordinates are given. This is my I, this is my V. This is negative resistance device. Now you will be asked to use the negative resistance device. This is my NR device here. Okay, this is my NR. Now instead of applying the voltage here, I am applying a voltage here. I am applying a bias now. This is my V, this is my R. So I ask you to plot the characteristic now with respect to this V and this I. This is voltage which will be varying, this V and this is my I. You plot the characteristic of this V. So I am calling this my V, I'll call this as my V dash. So V prime R is some kind of a biasing structure given to you. This device is given to you with this kind of characteristics. Either slope is given, or it may be, even if it is some kind of curvature or so, exponential rise, exponential decay, whatever is there. Even then, from these coordinates, I think you will be able to devise what is going to be my this V. With respect to this V and this I, this characteristic curve is matching. With respect to this V and this I, this characteristic curve is plotted. You have to plot it with respect to V dash and I. I will be DC, of course. V dash and I. What will be this characteristic curve? From here, it will be derived for here, because V dash and R are controlling the voltage V across the negative resistance device. So you have to plot V dash versus I. When we say plot the characteristic of the composite circuit, then you have to go like that. Is that okay? So what I do here, I'll find at this point two equations. One is this, one is this. This is given, this is given. That means when this current I is this IV and this voltage is VV in the characteristic curve, what is going to be the equation with equation for V dash now? So V dash will be coming as a function of I and V. Okay, this V is fixed. If this I is fixed, corresponding to that, what is my V dash? That will be this point. It will be this point, it will be my V dash. V dash. What will be, if this is a circuit, what will be my IV dash? It will be same thing as IV. You can analyze and see. IV will remain the same. VV dash will become, so VV dash is coming at this point, which gives me this VV at this point, this VV, this value. So here the breakover condition occurs and it comes like that. You come to this point. Okay, then you have to find this volt, this thing also. So this thing means your V prime will be VP prime. So this is my VP prime. When I apply here, I should get my V prime, VP here. This is my VP. For this VP, what should be my V dash P? Where current is known to me, by that you can solve it. So your R will play the role in computing that. So here also VP dash will change, I will remain the same as your IP. Now here again we find the same third point. You can compute here also. When it comes here as your V maximum operating point dash, how much is corresponding V? This is your V max. So this value I put here, this current I'll put here, I'll find what is my V dash for that, and I will remain the same. For this case, I remain the same. So from here to here, you can join it like this. Or even if you want, you can take the same shape by curve fitting method to make it like that. If somebody has not given the straight line, you can go by the curve fitting method. Could I answer something of your use in the examination? I think this was already known to you, but now I have highlighted as some kind of a possible question. Okay?
Yes, sir.
And I'm coming to the other one. I'm asking because if it's not understood, somebody can raise the issue like that. Yeah, I'm here now. Same NR device. Same characteristic given the way I have given that, same is given like that. Now I use this resistance like this. So this becomes my V dash, this is my R, and VI characteristic is given. Okay, so V dash and this V, it will be the same. What about the current? Current will be changing because the current will be flowing through this R. Okay, that current will be subtracted from this current going inside that. Okay, so that will be, here is my total current. I think if you want, you can put a resistance here also. You can put a resistance, but anyway, I'm leaving up to you. It is like that. Okay, suppose it is this. How are you going to find I? Which I you are plotting? I going from the device is this. Okay, I want this I dash, and this is my V dash. V dash and I dash I want to plot. So I have to plot now V dash and I dash. Okay, so V dash will be the same thing. The way this is my VV, my IV will be changed. IV dash will be changed because this current is this current plus this current, and this current flows when the voltage here is somewhere here. If this is a voltage, what current is flowing through that? Accordingly, you find what current is a total current coming across that. So that's why IV dash is changing. Okay. So its characteristic curve will be something like this. Here you compute, this will be your IP dash, and VP dash will be the same as VP. Similarly, at this point also you can compute if somebody has asked there. So that way, for the composite structure, you can calculate these things. Okay. Another question, examiner may try to confuse you, but it should not be confused by that. That's why I am taking all varieties for your discussion. See, yeah, here is my NR device. Characteristic will be given to me. Here I have given a resistance. I have given a current source, that is my I. This is my R2, for example. Here there will be R1. Here this voltage, capital V, don't say capital V, I'm saying V dash is applied. Like a VI is plotted, the voltage V dash is applied. Characteristic is given, I want to find, okay, this is my V dash, okay, this is my V dash, and I call it with respect to the voltage source, I'm going for it, okay, V dash, and here it will be I dash now. It will be one current through this, one current through this. This current will be now changing according to this V dash and this I dash. V dash and I dash will change this current. When this current is changed, your characteristic will be changed according to the VI characteristic that is given to you. Now current value is changing. So voltage drop across this is also changing according to that characteristic. And that voltage drop will appear across the NR device. Okay. So this is the one I am interested in finding. This is my V. Operational V, and this I am calling as operational I. If you are not finding comfortable, tell me, I will do that for you. Procedure I am telling, you find a Thevenin's equivalent voltage source here. You find Thevenin's equivalent resistance. Current source and voltage source both are given, the V, the I. So find VTH and RTH, and your NR device is connected here. This characteristic is already plotted. Okay, this characteristic is already plotted in the curve. Now we want to find from this VI characteristic, this V and this I characteristic will be changing according to this VTH. What is the value of VTH? That will be changing the voltage here. So you'll be finding here VTH versus I dash, and that plot will be something like that. It will be changing according to that. Can you do it now? I think from the characteristic curve of this one, you substitute that value of voltage here, that value of current here, you can find what is the VTH that is applied here. And VTH will be coming according to this I and this V applied over here. With respect to I and V, your VTH will be changing. So if you want to plot with respect to this I and here this I going through the device, you can plot it. So new characteristic of the composite system you have plotted. You can be asked to plot again this V dash, okay, when I is affecting your calculation, but you're plotting against with respect to V dash, this I. So you'll be having a characteristic curve like that. So it can be VTH, it can be your, I can say I composite. So characteristic curve will be accordingly changing, and this you will be asked to find only these points. 0 will remain, of course, as a 0. If somebody has given here also, you have to ask, you are asked to find these points over here. Will you be able to do it? Same thing is appearing in other form also. I have worked out here. Yeah, other form is, here is my V. After V, okay, let me go directly here. That's why this I did have seen. Here is my NR device. Here there is a resistance. Through that I am applying a DC voltage here. This is not changing. Here also this I is not changing in normal cases. I is not changing, only this V is changing. So you have to plot versus V dash versus this, sorry, I versus V dash. This I passing through this VTH, this I versus V dash. Normally we plot like that. Here a voltage V will be given. Here a small voltage V is given as a, that is the one that is changing. This is my NR device. This will be my R. Here again same thing you have to do, because for the NR, those 3-4 points are already given. You will be able to compute this transformed version of this V along with this capital V, which is fixed. What is going to be the small value V, so that this becomes that particular coordinate system's point. And accordingly the current is known. So when this current is known, how much current is coming through this and through this, you have to use Thevenin's equivalent circuit for that, and you can define that how much current will be coming through that. You will be able to plot with shifting in the coordinate point in that previous curve. Okay, so with respect to voltage source, current source I have given. Others are simpler than that. I think you can make it like this. Here is my resistance. Here is my voltage source. Here is my NR device. Okay. And here is my resistance with a current source, with a voltage source like that. This is my small v, this will be my capital V, this will be my R2, this will be my R1, and you are finding voltage across this and current passing through this, that is given. But you are plotting with respect to this V and the current flowing through this. That will be the same thing as current flowing through the NR device. So NR device current, that is not changing. But here the voltage will be changing. You can plot like that. This is another circuit that will be able to answer quickly. Shall I go to some other circuit? It's okay or not? Okay. Another circuit will be, let us say, UJT. Okay. UJT is biased like that. This is my UJT. bias through a resistance and this voltage, it is biased like that. Here is my this thing, this is my emitter, this is my B2, this is my B1, this is my R, this. Okay. There can be several questions that can be asked. One is that what is the value of cut-in voltage V gamma? V gamma should be smaller than or equal to some voltage that is coming at this point. That I have already given. This is my V. So V divided by R plus RB1 plus RB2 into what? I want voltage between this and the ground. Okay, this voltage V gamma should be like this. So this and ground will be what? Okay, so this voltage V divided by the current. So in this current into RB1. Okay, RB1 into V divided by R plus RB1 plus RB2. Okay. Now, in some questions we will ask that UJT characteristic is given when it is your V versus I. This is a characteristic given with respect to this V, and same V, not a DC bias, same V is applied here. Well, okay, this voltage that was applied here initially that gave me this characteristic. Now this voltage has come to this point. The same source has come at this point. Okay, so this it only had by VBB divided by this into RB1. Now I am here, so this will be your VBB. What is the VBB? Earlier it was VBB into RB1 by R plus RB1 plus RB2. R is not there, of course. It was there initially. Okay, that was my V gamma. Now it is changed, so it will become VBB dash now. This VBB at this point will become VB dash. So it will be your VBB dash into RB1 by RB1 plus RB2. What is VBB1 dash? That means your this V minus this current into R. Okay, V by R plus R1 RB1 plus RB2 into R. Okay, so this will be my VB dash. Okay, V minus VB, it's all like that. So whatever question is asked accordingly, you can put the value of V, you get the answer that way. I'm taking as V as something different voltage here. This V will be taken outside. Okay, it will be 1 minus R by this thing. Okay, this was your VBB, remember. It was V minus this thing. Okay, this whole thing was my VBB. Is this thing. So what is going to be the voltage at this point? Your V gamma should be less than equal to, I'll make this one is not your VBB supply. So I'll put voltage over here. That will be what? This new VBB, V into 1 minus R by this summation, okay, into RB1 divided by RB1 plus RB2. This one is taken as your eta. If this here taken as eta, this will be your RB1 plus RB2. If R is smaller than that, this will be that value. So R by this RBB, or I can put this R1, RB1 combined here. That will be this. So your this V gamma should be smaller than equal to this. Only then it will fire. So to fire that, okay, this V should be adjusted so that this whole quantity becomes greater than V gamma, or at least it is equal to V gamma. Only then it will fire, otherwise it will not fire. Is that okay? Am I going fast or is okay? Okay. Okay, sir. Okay, fine. Now, if fast speed, then you can stop me. I'm coming to some other solutions. Yeah, other solutions are like this. Suppose this is my NR device. NR device is there. Here, gate voltage I'm not considering. Okay, this is my NR device. Okay, it's fine. Now I have biased it. With this characteristic is given. This is my R, this is my V. Question may be asked, find the operating point. V and R are chosen by you in the design. At what operating point this NR device you intend to bias? It goes like that. Okay, V and R are fixed by somebody. You are telling them that your operating point is good or not good, like that. So what will be there? Characteristics will be given. Once again, curves will be given. Simple thing will be straight line. It goes like that. This is my I. This is my V. So this coordinate, this coordinate, this coordinate, these three coordinates are given. Okay, like this. Maybe if this slope is saying that forward resistance, your positive resistance is the same, then this slope and this slope will be same. This will be your positive resistance, R positive, 1 by R positive, no? Is the slope, and here this slope will be 1 by R negative. Okay, so this slope goes, sorry, it is 1 by R positive is also 1 by R positive. R positive is given to you in the form of these coordinates. These coordinates are there, straight line you are assuming. You can find what is the equation of this straight line by computing the slope. Here you have computed the slope. You want to find equation of this straight line. How to find in between? Unless you extend it to cut here, y equal to mx plus c we cannot get. So this will be extended to cut here. This is extended like that. This is extended like that. So here it is cutting. So this will be your, this is your C. So your equation will be y equal to mx. X is your V now. You have to compute what is my C. M you have computed. Okay. You have to find where it will be meeting this axis. Okay, so you have got it like that. Equation of this line you have got. Equation of this line is easy. Suppose I want to get equation of this line, you have to extend it backwards. This will become your C dash now. Okay, so your y will be mx plus C dash. Third line will be coming like that. So this intersection unless it comes, you cannot. So you should not be in a wrong position to answer that question. Now we can take up this and solve it. Now, what is the load line? How much is the maximum current flowing through NR, when NR flowing through that? That I consider here as I max. This I max is nothing but V by R. Okay, because on maximum current flow, the voltage drop here will become 0. It becomes a V by R. Okay, the I maximum. And what is my V max? V max is coming somewhere here. V max is coming somewhere here. I draw a straight line, which find to which curve it is cutting. If my V by R coming somewhere here, okay, so for the same V, if R is changed, it will be cutting somewhere here. Got the point? So how I get this position and this position? So equation of this is, okay, your I equal to, for the load line, I equal to mx. M is what? Mx, Ma will be delta V by delta I, isn't it? Sorry, delta I by delta y by delta x we take for the slope. So delta I by delta y will be negative. So it will be your minus 1 by R into the slope. Slope will be delta V will be your 1 by R only taken. Sorry, this is the slope. A into V plus C I max. That is your this capital V by R. A small v is the voltage that is coming across the as a variations along the load line. So this is for the load line. Now you take one by one all these lines. This line, take this line, you take this line. It will be cutting one of them, two of them, it may cut all three of them. Okay, so that you are doing, you can say your these are the load line that you have seen taken. Sir. Yes. Okay. Okay. I've taken like that. You will be able to find it from here. That where which of the category? This is a straight line you have got. You have line 1 or slope 1. You can say line 1 is a positive resistance, positive slope. That you can put here as an equation. Solve for the I and V from there. This I is changing, this V is changing. Capital V and R are the same. So you solve for that. This line equation you have already got it. Y equal to mx plus C. So line 1 you have done. You can do it for line 2. If there is no solution existing for line number 2, that means it is not touching that line. Similarly, line number 3 you can see if it is having a solution with slope, load line and this. If there is a point common found, then the operating point lies on this also. The operating point will be lying on more than one, like if this is one, here it is lying at this point. Okay, operating point, if I'm taking at this, it is cutting at this point. If I'm take my V and I like that, this kind of thing. So this will be my V. So V by R will be this by I max. And this will be having solution, okay, valid for this line, for this line, and for this line both. So I will be having 3 different operating points. So which one you are using? According to your bias, you can now decide A stable, pi stable, and multi stable, your mono stable, those operations. Okay, so that way V by R you have got. Another question will be, yeah, actually, I think I have gone for the second answer actually. V and R are given, only one load line is there. It is cutting to one of them, that becomes the operating point. Next question may come that your for operating point IO and VO, find R and V. You have to find this also. So here again, same thing you are going to do. IO and VO, this is the operating point. It will be lying in the characteristic curve, one of the places. If there are more than one options given, then you have to consider that. If only one is given, it will lie on any one of the curves. So you have chosen the operating point, and now load line you have already drawn according to this minus 1 by R into V plus V by R. You find what is the solution for I and V with respect to the operating point. I mean, where it is contained on which line, that line or this line. Where they intersect at the same point, you can compute what is my V and what is my R from these equations. Okay? So V and R can be computed because I is given to you and V is given to you. One equation you get from the load line, another equation you get from one of these 3 lines if only one value is given. If 2 values are given, you have to find at 2 places what is V by R that satisfies both the cases. I think that question will be more involved. There you have to take other singularity and other constraints, so that will not be anticipated. So only one option will be given. Find your design parameter V and R so that your operating point lies over there. So this I have completed from my side, whatever tutorial was concerned. Now what is the opinion, students? I can take some questions. Okay, so very few people are there today. That's why I put tutorial in the end, because all are not interested in the tutorial discussion. So in the end I put those who are not interested, I think they are free to do so. Because theory class I keep on mixing like that. Some of your friends might be on that side where they are not able to understand something. So theory I complete, regular, here I have completed this. Okay, so Monday we are having exam. Wish you good luck for the quiz 4.
Thank you, sir.
Okay. Good day, I'll take leave now. Professor Sen Gupta is not there today, but perhaps he is making arrangement for the test, etc. for the Monday. Okay, fine. Thank you. Thank you. See you again.